Good evening, students. Am I audible?
Yes,
Yes,
sir.
Okay. Just give me a second. Yes. So I hope you guys are able to see, right?
Yes, sir.
Yes. Listen. So we'll discuss few problems from the motion in a plane. I think we have completed vectors already. So vectors problems we have completed. Now we will solve some problems that are based on projectile motion. Did we complete projectile motion also? I don't think so. Right. We'll do them. So let's start with the third problem. See this sheet, I hope you guys have it with you already. If anybody has joined after vectors, don't worry, I'll share the sheet again in the group after this class. Okay. So as of now, you can use the textbook. You can look at the screen and try to answer it. So there is an object which is moving on a circular path with velocity v vector at any given instant. When it completes half rotation, what is the change in its velocity? Okay. One thing they should have mentioned is it should be a uniform circular motion. It is then you can solve the problem with the given data. So if there is an object in a uniform circular path or motion with moving with velocity v at a given instant, when it completes half revolution, what will be the change in its velocity? Let's visualize it. Okay. Anybody who can tell me how to solve this? So with respect to a circular, let's assume that the object is revolving in anti-clockwise direction with an angular velocity omega. Okay, forget about angular velocity also. It revolves in the anti-clockwise direction. Okay, so what is the speed of it? They have given the velocity at any instant is v. So when it has completed half a revolution, then the velocity at this point will be in this direction. Accepted?
Sir, half, sir. You drawn for quarter.
When it completes half rotation. Okay. So when it completes half a rotation, what is going to be the change in velocity? Right. So can I say at point A, so I always solve the problem using the basic reference coordinate system. I take this as x-axis, this as y-axis, x dash and y dash. Okay. So what is the velocity of the particle at point A? Is it not v I cap? What is the velocity of the particle at point B? Sorry, v j cap. And velocity at point B will be v of minus j cap. Correct? So what is the change in velocity that is taking place? It is vb vector minus va vector. So vb vector is v with minus j cap minus va vector is v with plus j cap. So what will you get? Minus 2 times vj cap or 2 times v with a minus j cap. Am I right, guys? So what will be the answer?
B.
Okay, you know why it is B? Because it is minus 2 times V j cap. So V and J cap collectively can be called as V vector. Right? That is why it is -2 into V vector. I hope you guys understood this concept. There's a good problem actually. Though it's a simple one, but a good one. I hope it is clear, guys.
Yes, sir.
Okay. Now see. Now what about the fifth one? So coordinates of a particle which is moving in a plane at any time t are given by the equation x is equal to alpha t square, y is equal to beta t square. Now our job is to find the magnitude of velocity of this particle. So x is equal to alpha t square. So what is dx by dt? It is 2 times alpha into t. Similarly, y is equal to beta t square, then dy by dt will be equal to 2 times beta t. Correct? So this is velocity along x direction. This is a velocity along y direction. Now they're asking the magnitude of velocity. How do you find the magnitude of velocity, guys? So generally, velocity, if you write it in the vector form, velocity vector will be equal to Vx I cap plus Vy j cap. Correct? So what is Vx I cap? That is 2 alpha t I cap plus this will be 2 times beta t j cap. So what is the magnitude of this, guys? It will be root of 2 alpha the whole square plus 2 beta the whole square. So what will be the answer? 2 into root of alpha square plus beta square. Right. Done, guys. So I want you all to try the next problem and tell me the answer. This we have already solved it from NCERT, but I want you to try it again. In a projectile motion, if the maximum height h is equal to half of the range, then the angle of projection is how much? Do it fast and tell me. What is the answer, guys?
Sir,
Tell me.
sir, sine square theta can be written as what in forms of trigonometry?
You need not change sine square theta. You just change sine 2 theta as 2 sine theta cos theta. That will solve the problem. But if you want to
So
know the
then
idea,
that's answer is tan inverse of my 1.
Tan inverse of 1 is 45 degrees. Okay. So R is equal to H, H is equal to R by 2. Maximum height is U square sine square theta by 2G is equal to U square sine 2 theta divided by G. G and G will get cancelled. U square is gone. Sine square theta is equal to, I don't think so, check it once. Tan theta should be 4.
Sir, it should be half, right? Half of u square sine 2 theta.
Oh, half is there, sorry. Yeah, then 2 and 2 will get cancelled. Then also you'll have a 2 node. For sine 2 theta is 2 sine theta cos theta. Yeah. So tan inverse 2. Answer should be tan inverse 2. I hope you guys got it.
Yes, sir.
Right, that's good. Now try the next one. An object is projected with initial velocity v vector if the range of the object is double the maximum height. So it's same as this problem. R is equal to 2h. The range is equal to 2h. Then they're asking its range is how much. Now the question is different. Now if R is equal to 2h, how do you find the value of R? So again, tan theta is equal to 2. When tan theta is 2, how much will sine theta be? Sine theta will be 2 divided by root 5 and cos theta will be 1 divided by root 5. I hope you guys know how to find this, right? When tan theta is 2, you know how to find the other trigonometric ratios.
Yes, sir.
Okay. Now they're asking range. No, range is u square sine 2 theta divided by g. So u square into 2 into sine theta is 2 by root 5. Cos theta is 1 by root 5, the whole divided by g. So it is 4u square divided by 5g. Is there an option like that? Yeah.
Sir, can you once explain what you did in the previous sum?
Why?
Six, sir.
No, I didn't understand what you're asking. Why I?
Sir, in the sixth sum, I'm like it is not clear what you did, sir. You
I wrote the
equated and then
formula.
how did you cancel? Yes, sir.
How did I cancel what? U square got cancelled. 2g and 2g got cancelled. Sine square theta is equal to 2 sine theta cos theta. Sine theta sine theta. So tan theta will be equal to 2. That's it. Am I clear? Am I clear or not?
Sir, in the seventh question, it should be 4u square, right?
No, 4u square by 5g. No, here they told initial velocity is v. No, they use the symbol v. So it is 4v square by 5g. Okay. Shall we move on to the next one? This one. Look at the ninth one. You guys know this. Solve and tell me. How to do, guys? So rain is falling in the downward direction with a velocity of 4 km per hour. So velocity of rain is 4 minus j cap. A man is walking on a straight road with a velocity of 3 km per hour. So velocity of man is 3 I cap. Now they're asking the apparent velocity of the rain with respect to man. So velocity of rain with respect to man is velocity of rain minus velocity of man in the vector form. So this will be minus 4j cap minus 3I cap. So what will be the value, guys? What will be the magnitude? Velocity of rain with respect to man will be root
5.
of 4. So 3, 4, 5. Answer is 5 kilometers per hour. Okay. Now do the 10th one and tell me fast. For which angle of projection the range and its maximum height will be equal? These are all 1 minute problem, guys. I don't know why you're taking so much time. Make it fast. Range is u square sine 2 theta by g is equal to maximum height is u square sine square theta divided by 2g. G and g will get cancelled. 2 sine theta cos theta is equal to sine square theta by 2.
Sir, option 2.
Sir, option B.
Correct. So tan theta should be 4. So obviously it will be theta is equal to tan inverse of 4. That's right. Now, I want you guys to try the 11th one with the knowledge from the third problem. Okay, just like how I explained the third problem, this is something similar to it. I want you guys to try and tell me what is the answer. How to do, guys?
Sir, is it option C?
Yes, sir.
Option C. So how did you do? Can you tell me the steps?
Sir, change in velocity is VB minus VA. So that's 30 J cap minus 30 minus I cap. So magnitude of resultant will be
30 J cap and 30 minus I cap. Correct. Yeah, magnitude of resultant will be 30,
yes, sir.
30 root 2. Correct. In the, what did you say? Option
Sir,
B
I
or
did
C?
triangle.
No, however you do,
I did
option will
triangle
be
law
the
of
same.
addition.
Both are same. The triangle and parallelogram law of vectors, they both are same. But what is the
Okay,
answer you got?
Southwest, sir.
30 root 2. Why
Northwest.
would it be so? It should be northwest. No, motorboat is moving to a northward with the velocity. If we turn towards the west at the same speed, then the change in its velocity. Okay, did you take it like this then? Okay, I understood what you would have done.
Sir, I took the resultant as in the southward direction.
So it will be like this. But if you
Okay,
have
sir,
applied triangle of vectors, you would have got something like this. Right, that is not the resultant actually.
Sir, no, sir. Actually, the diagram which you drew previously, in that diagram itself, the resultant is towards southwest.
Where is it southwest from? So there's there no. So this is 30 J kappa. This is 30 with minus I kappa. So what is the direction of this? It is parallelogram, right? Because they are co-initial vectors, like the way I took it. It is 30 root 2. So 30 root 2 option is there in B and C. Which one is right? This is north. This is west.
Sir, no, sir. What I was telling is that in the same diagram, instead of drawing the resultant as from the initial point, we draw from the head of 30 J cap to the head of 30 I minus I cap.
That is what you're not supposed to do. Then you didn't understand this concept. Triangle law of addition. When do you use it? When do you use triangle law of addition? When you have continuous
When
vectors. What do you mean by continuous vectors? That is,
when they are in
take out the
order.
first. They are in order, right? Whereas you use parallelogram law when they are co-initial. So here, what kind of vector do you have?
Co-initial.
Yes, that is the reason you need to use parallelogram. So the answer is northwest. Don't make a mistake. Okay, that is the direction in which the change is taking place. Means, if I'm not wrong, this is the diagram you would have drawn in your notes. 1 minute. So this is the diagram you would have drawn in your notes. You would have taken this as 30 with minus I, correct? Then if you take the resultant like this, then it is wrong. Because the resultant can be taken along the diagonal only when they form a parallelogram with co-initial vectors. Here, the vectors are in order. Guys, are you able to understand what I'm trying to say? They are in order. So what I did is, I took an equal vector exactly parallel to this at the bottom, such that it becomes the co-initial vector of 30J. Then I did it. Here, mark it as important and practice it again. Okay. Next. 12th one. See, from the 12th one, I would like to tell you some important points. Please make a note of all those. So if the resultant of vector A bar and B bar makes an angle alpha with A vector and beta with B vector. Okay. So there are two vectors, A vector and B vector. And the resultant of this makes an angle alpha with A vector and beta with B vector. Okay. Now they are asking the first option whether alpha is going to be less than beta. If A is less than B, that is the magnitude of A is less than B, then the value of alpha should be less than beta. or if the magnitude of A is greater than magnitude of B, then alpha will be less than beta, and if A is equal to B, alpha will be less than beta. Okay. First, I would like to explain each and everything. Listen to this carefully. A is not always. So what do I mean? What do they mean by alpha is less than beta? Irrespective of whether you have a greater magnitude of A or a greater magnitude of B, alpha is always less than beta. No, that is not the case, because the angle made by the resultant with respect to either of the vectors is magnitude dependent. So when I say magnitude dependent, option B, C, or D is possible. But if I look at B, what it is telling us, if the magnitude of A is less than magnitude of B, then alpha is less than beta. I would like to tell you a theory, guys. Let's say there is a force of 5 Newton acting like this and 10 Newton acting like this. The resultant is there, no? The resultant will always be closer to the one which is making a greater angle. Okay, I repeat, the resultant will always be closer to the vector which is having a greater magnitude. The resultant is closer to the vector which is having a greater magnitude. So if I take this as alpha and this as beta, we know that 10 is greater than 5, then what will happen? Alpha is less than beta. What is happening to the inequality? They are inversely proportional to the magnitude. Am I right?
Yes, sir.
Right. So what is the answer? If A is
C.
less than B, alpha is less than beta, it is wrong. Had this been 5 and this been 10, then beta would have been less than alpha, because the resultant is closer to this. So answer will be C. The angle made by the resultant with the vectors is inversely proportional to whom? Inversely proportional to the magnitude. Then you can ask me what will happen in the case of D. Can you guys guess? If A is equal to B, if both the vectors are of equal magnitude, can you make a change here?
Then alpha is equal to beta.
Alpha will be equal to beta. There is an important point. Please make note of it. Okay. So all these are properties of parallelogram law of vectors. So according to parallelogram law, I hope you guys made a note. One last time I'm telling, listen to it carefully. If there are two co-initial vectors and the resultant is taken as a diagonal of the parallelogram, then the resultant will be closer to the vector with greater magnitude. First point. Resultant will be closer to the vector with a greater magnitude. That is the first point. And the second point is what? If both the vectors are of equal magnitude, then the resultant will be an angular bisector. Okay. Moving on to the next problem. This one you guys are going to do. So linear speed of the tip of a second alarm of a clock is V. The magnitude of the change in velocity in 15 seconds. It is something similar to the third problem. Guys, do it and tell me. Let's see how many of you requisited. There is also only one step to this.
Sir, is it root 2v?
Correct. So how you get this? This is the second hand. Okay. Let's say this is the second hand. So obviously clockwise is the direction in which the second hand is going to revolve. So let's say here the velocity is vi cap. After 15 seconds, it will be here, which is v of minus j cap. Now they ask what is the change in velocity. So delta v vector is equal to v final vector minus v initial vector. So I hope you guys know the difference between, see, listen to this carefully again. Whenever a problem is given, you apply the formula of v1 minus v2 in two scenarios. One is in the case of relative motion. Second is in the case of change of velocity or change in something for that matter. Okay. So wherever you see the word change, you always should apply the formula final minus initial. Okay. Whereas if it is relative velocity of 1 with respect to 2, then you should write it as 1 minus 2. Then you need to be clear. So whatever is the order that is formed for relative, you need to follow that order. Whereas when you see the word change, it is always final minus initial. So here it will be minus vj vector minus vi vector. This is delta v vector. So what will be the magnitude of delta v vector? It will be square root of v square plus v square, which will be root 2. That's right. 14th one, guys. The velocity of a boat with respect, actually not respected, with respect to ground is 3i cap plus 4j cap, and the velocity of water with respect to ground is minus 3i cap plus minus 4j cap. Hence, the velocity of the boat with respect to water is how much? This you guys can do it fast. By looking at the question, you can tell the answer. What is it? So velocity of boat with respect to water is velocity of boat minus velocity of water. So what will be the answer? Basic subtraction of vectors, guys.
Is it A?
Ava.
Sir, actually, if velocity of boat with respect to water, water should come for a boat.
Boat should come first. Velocity of one with
Sir,
respect to
option
two is
C.
hot. Then option C is right. So velocity of boat with respect to water means velocity of boat minus velocity of water. Here, order is important. Next, 15th one, guys. When the angle of projection is 25 degrees, the range of the projectile is R. Now, if the angle of projection is dash, its range will remain the same. So, when will the range of projectile be the same?
When the angles are complementary.
Yes. So, what will be the answer?
65.
So, range of projectiles will be the same if their angles are complementary, provided there is an important point that you need
The
to
velocity, initial velocity is same.
provided the velocities of projection are the same. Very good. Okay. 16th one is vectors that we have already solved. 17th one. The acceleration of a projectile at its maximum height is how much? Zero G maximum minimum.
So, is it minimum?
Right. Right. When a particle is moving,
Sir,
ah,
sir, why can't it be G?
I don't know, you tell me. What do you think? When a part, see, why are you guys not thinking of the logic? When initial velocity u is given to this particle, right? I've already told you the derivation. What is the acceleration of the particle along x direction?
0.
What is the acceleration of particle along y direction? It is minus g. So what is the only acceleration acting on this particle throughout its journey?
Y component.
G. That's the answer. Why is it going to be minimum or maximum? It has nothing to do with maximum height. Okay. So had they asked, what is the acceleration of the projectile? See, for that matter, acceleration of the projectile at any point in its motion is g only. It's neither becoming maximum nor minimum, or it is
Sir, then
becoming
it should
zero.
be minus g, right?
No need. When they say acceleration, you can take it as magnitude. See, this minus sign depends on which direction you take it as negative. Correct?
Okay, sir.
I told you there is no hard and fast rule in physics that only downward direction is negative. It's up to you. That is why they give the options like this. Okay, I'll be very specific about it. They'll not give you the option as G and minus G. If they give this kind of an option, they should clearly mention it in the question that which direction is taken as negative. If not, the question is wrong. Okay. 18th. An object is projected at an angle of 45 degrees with the horizontal with kinetic energy K. Its kinetic energy at maximum height is.
Is it 0?
No. Why will it be 0?
No, sir. Sorry, sir.
It is coming to instantaneous rest only in the vertical direction. You guys need to recollect the concepts. So when an object is projected in the projectile motion, which velocity remains constant? I've told this to you guys already. U cos theta, and this is U sin theta, and this is U. If I take this as theta, correct? So what is going to be the horizontal component of velocity? Is it not always a constant, U cos theta? Whereas at the highest point, U cos theta is there, but the vertical velocity here is 0.
0. Sir, K
So
by
what
2
is the
then.
kind of, so half into m into U cos theta the whole square. Correct, Ada? So half mu square into cos square theta. How much is it? Cos 45 is 1 by root 2. 1 by root 2 the whole square. So half mu square into 1 by 2. So half mu square is k. K by 2. So its kinetic energy at the highest point will become half of the initial kinetic energy. Clear? Now do the 19th one, make it fast and tell me. The velocity of a boat in a river of width 1 kilometer is 5 kilometers per hour. The boat crosses the river in 15 minutes, making over the shortest path. Hence, the velocity of flow of river is how much? This is a slightly tricky one. Let me help you. Are you guys able to think of the diagram? So, velocity of the boat to the river of width 1 kilometer. So, the width of the river is 1 kilometer. And in how much time is the boat able to reach the opposite end? 15 minutes. Better. So velocity of the river will be in this direction. That is what we are asked to find. So what do you mean by shortest path? When you have two parallel lines, the shortest path between two parallel lines is always the perpendicular distance between them. Correct? Sir?
Yes,
So
sir.
if it has to be perpendicular distance, then suppose the boat would have started like this. Okay. Suppose the boat would have started like this, then what would have happened? It would have got drifted and it would have reached this point on the opposite side. So this would have not been the shortest path. This would have been the shortest time. So for the boat to reach the shortest path, what it is supposed to do is it should start at some inclination with respect to the river. So the velocity of boat with respect to river is how much? How much are they given? It is 5 km per hour. Then what is going to be the velocity of boat, guys?
Sir, 4.
So it will be 4. Okay. So what will be the velocity of river then?
3.
Sir, could you repeat how it's 4?
Because 1 kilometer divided by 15. Right? Speed. So velocity of boat is equal to how much? Speed is equal to distance by time. So how much is the distance it is covering? 1000 meters. Okay, it is in kilometer only, no? So let's write it in kilometer itself. 1 kilometer divided by the time is 1 by 15. That is 1 by 4th of
Yeah,
an
1
hour.
by 4. Yes, sir.
Now you got it? It is 4 km per hour. So velocity of river will be 3. Okay. 20th one is an interesting question. So bullets are fired with same initial velocity be in different directions on a plane surface. The bullets fall on the maximum area of dash on this surface. See, guys, try to understand. Okay, this is a surface. There is a person standing here and he is firing the bullets so that they go and fall here. Okay. So what they are trying to say is when you see from the top view, when you see from this side, okay, since the bullets are fired with the same initial velocity in different directions, and the question is very clear, there is a hidden information. The bullets would fall on maximum area. When will you get maximum area? You will be, if you observe from the top, no, what you can see is you can see these kind of dots. So if you join all those dots, what shape do you think you're going to get? You will get a circle. And they want the circle to have the maximum area, and the circle will have maximum area when it has maximum radius. So with respect to this person, what is this radius? Is that not the range?
Yes, sir.
Right? So when is the maximum range possible, guys?
Sir, if sine 2 theta is equal to 1.
That is when theta is equal to 45 degrees. So the maximum range is u square by g. So area is pi r square. So pi into u square by g the whole square, that is u power 4 by g square. So pi into u power 4 by g square is the answer. It's a good question. I think it was some JEE question few years back. Okay.
Sir, I have a doubt, sir.
Then
Sir, what if the theta is 0 degrees?
what if theta is 0 degrees? Sir? Theta is 0 degrees, it cannot be a projectile. Bullets are fired with initial range and they are fired in different directions on a plane surface. So he's standing on a surface.
Sir,
and it is,
but they never mentioned that it's inclined with the horizontal.
No. See, this is the meaning. On a plane surface, what do you mean by on a plane surface? Had it been 0 degrees, person standing like this, if the velocity is given like this, right? Since we know that in horizontal direction, we don't take, theoretically at least, we say that in the horizontal direction, there is no velocity, I mean acceleration. What would have happened to this bullet? This bullet would have traveled to a longer distance. Then the maximum range would have been infinite. Then how will you even get area?
Sir, how is it infinite?
How is it?
The gravity is still acting, right? So at some point it should fall on the ground.
But the velocity, see, Newton's first law says an object will continue to move in a state of rest or an uniform motion unless and until a force is applied on it in the direction of its motion. Okay. You're able to understand that point? You mean to say it will go and fall like this?
Sir, but after a long period of time.
It will take a long period, but how will you calculate it? How will you calculate this distance then? What time is it going to go and hit? The question is very clear that the angle of projection is in such a way that it is hit on a plane surface such that it is able to cover maximum area. Theoretically, this is also projectile motion only, but in projectile motion, we know the concept that range is going to be maximum only when the angle of projection is 45 degrees. So when it is 0, the range is not going to be maximum. Am I right?
Yes, sir.
That is the reason. So the hint here is maximum area. Maximum area is derived from maximum radius. Maximum radius is possible when it is maximum range. Okay. Now,
Okay, sir.
the next problem is I want you guys to do it. For a projectile motion, y is equal to 8t minus 5t square, x is equal to 60, where x and y are in meter and t is in second. The initial velocity of this projectile is how much? So what is dx by dt, guys? 6. What is dy by dt? 8 minus 10t. So what do you mean by initial velocity? T is equal to 0.
The 10, sir.
Yes. So initial velocity T is equal to 0 if you substitute. So horizontal is 6, vertical is 8. The resultant will be root of 6 square plus 8 square, that will be 10. 10 meters. Okay. That's it. The remaining problems you can try. I hope everybody has collected this thing, right? You have collected your material, study material. Those who have not collected, ensure you collect it within this week. Okay. And I hope you guys remember this Sunday. For Saturday, you guys have chemistry class. Sunday from 5 to 6:30 p.m. there will be a test in this chapter, motion in a plane. And the next important thing is it is going to be subjective. I'm not going to give objective because I want to know how much you people have understood. Okay. So study it according to the previous year pattern only and ensure you write the test in that way, because I want elaborate answers to analyze how much you people have understood this concept, and this is very, very important one. Okay. So prepare well. Any other doubts from today's class? Tell me.
Sir, this week I have midterm exams, sir, so I cannot write the test this week.
Okay, those who are not able to write, let me know that.
Okay, sir.
that's it, guys. We'll wind up. I'll start the 5th chapter tomorrow, that is laws of motion. It's an interesting one and an important one also. Okay. I'll see you all tomorrow.
Thank you, sir.
Thank you,
So
sir.
this Sunday 5 to 6:30, right?
Yes.
Okay.
Sir,
Tell me.
sir, can I buy those books today?
No, you need not buy it. Right? You're already a
Yeah, I
physics
just
student.
get
Go
it,
and
sir.
take it.
So can I get it
Yeah,
today,
you
sir?
go. Yeah, you can go before. Try to go before 6 now.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Yes. Sir.